Welcome students, we are expected to integrate integral dx over tan squared x positive sin squared x. So what I wish to do is I would like to take tan squared x out. This would give me tan squared x of 1 positive. Now sin squared x is there. I can always get sin squared x from tan squared x, but I do not want the cos squared x in the denominator. So to get rid of that cos squared x which is coming inside, I will have to multiply this, or I would say just have cos squared x over there. So if tan squared x comes over inside, this is going to be tan squared x times cos squared x, but tan squared x is sin squared x divided by cos squared x. This is actually multiplied with cos squared x, and cos squared gets cancelled, giving me sin squared x. Okay, so I hope you got that point. So this is what we've got. Now what I wish to do is I would like to multiply by secant squared x the numerator and secant squared x the denominator. So this is going to be integral secant squared x dx divided by, now I will keep tan squared x outside, then I will push in secant squared x. So this is going to be secant squared x plus secant squared x is coming inside. We know that secant squared x is 1 over cos squared x. So when you multiply with cos squared x gets vanished. So this is what I've got. But I also know a formula which is secant squared x negative tan squared x is equal to 1. So from here I can write secant squared x is equal to 1 positive tan squared x. So substitute this over here. So this is going to be integral secant squared x dx divided by tan squared x of 1 positive tan squared x positive 1. So this is equal to integral secant squared x dx divided by, I can add this and I will have tan squared x of 2 positive tan squared x. Okay, fair enough. Now let me take tan x is equal to some u. I differentiate tan x, I get secant squared x dx is equal to du. So this is taken care of. So this is equal to du divided by u squared of 2 positive u squared. Okay. Now what I wish to do is I'd like to consider u squared of 2 positive u squared. So this is going to be, I'm going to rewrite this as au positive b divided by one quantity u squared positive cu positive d divided by 2 positive u squared. Why? Because of the degree being 2, right? So I'm splitting it in this fashion. You cross multiply, you get 1 is equal to a times of u positive b of 2 positive u squared positive cu positive d of u. So this is what you have got. We will have to get rid of these, or I would say we'll have to find the value for a, b. No, you got to get the value for a, b, c and d. So let me proceed in that fashion. So I hope this is clear. This is a, b, c, d. Now I wish to take, let u be equal to 0. If u is equal to 0, what happens? This goes off and then this goes off. So you will have 2 times b, and this goes off and this goes off, right? This entire thing goes off because u being equal to 0. So clearly you have b is equal to 1 over 2. Okay, you can have that value. Next I'm going to take say for example u is equal to 1. Let u be equal to 1. If u is equal to 1, what do you get? You get a plus b, a plus b of 2 plus 1 plus c plus d of 1. On the left you got 1. So this is going to be 3 times a plus 3b positive c positive d, but b is equal to 1 over 2. You substitute that, you get 3 times a positive 3 over 2 positive c positive d, and you got a 1 there. You push this, you get 1 negative 3 over 2 is equal to 3a positive c positive d, and this is going to be negative 1 over 2 is equal to 3a positive c positive d. So that is one component. Now you take u is equal to negative 1. Let u be equal to negative 1. So if you were to substitute that u is equal to negative 1, what you will get? You will get a definitely you're going to get a positive value here. It doesn't matter because of the fact being this being 2. So 2 positive 1 3. So let me rewrite that. So negative a positive b 3, and then this is going to give me positive negative c positive d of negative 1. So I rewrite this. Of course you have 1 there. You get negative 3 times a. B is 1 over 2, so this is going to be 3 over 2, and then positive c negative d. So I push this to the other side. I get 1 negative 3 over 2 is negative 3a positive c negative d. This is going to give me negative 1 over 2, and this is negative 3a positive c negative d. Now I can actually equate these two equations, right? If I were to take this as 2 and take this as 3, I were to equate them. What do I get? You've got a negative 1 over 2, you have a negative 1 over 2. So I can clearly rewrite here 3a positive c positive d is equal to negative 3a positive c negative d. Now this, if I were to move, I get 6a. What happens here? You see that c comes over here, c gets cancelled, but d comes over here, I get 2d, right? So this is going to be 6a is equal to negative 2d. So you have a being equal to negative 1 over 3, negative 1 over 3 times d. So that is a good equation, I would say. So let me move on. Let me get a paper now, and I don't want to turn to the other side. Okay. So now what we are going to do is we will have to take another independent value. Okay, that's the only possibility that we have got. So what I will do is I will take let u be equal to, say, positive 2. If I take u is equal to positive 2, this is going to be 2 times a positive b, and 2 squared 4 positive 2 6, and then positive 2 times c positive d times u is equal to 1. Now I know b is equal to, the value of b is 1 over 2, so I can substitute that 1 over 2. So this is equal to 2 times a 1 over 2 times 6 positive 2 times c. In fact, I can distribute this 4c positive 2 times d. Now you bring the 6 inside, so you get 12 times a positive 3 positive 4c positive 2 times d is equal to 1. Now we got the value for a. Now a is equal to negative 1 over 3 times d. So you substitute that. This is going to be negative 12 times, or I would say the value of a is substituted, so that's going to give me a 3 there and a d there. So positive, in fact I can bring this 3 to the other side, so that is going to be negative 2 positive 4 times c and 2d here. So these two can be added, and that is going to give me 6 and negative 6 over 3, right? You get a 6 here, and you add a 6 with this, you get a negative 6 divided by 3 times d positive 4 times c is equal to negative 2. So you have negative 2 times d positive 4 times c is equal to negative 2. So this is another system we have got. Now we need to take one more value. So I have taken u is equal to 2. I will take u is equal to negative 2, and I will substitute it in this system over here. So that is going to give me 1 is equal to negative 2 times a positive b of u. This is going to be 4, right? 4 positive 2 is going to be 6, and then negative 2 times c positive d with negative 2. So just expand this. This is going to give me negative 12 times a positive b is 1 over 2. So we will get a 3 there, and this is going to be negative 4 times, or this should be positive 4 times c, negative 2 times d is equal to 1. So you move this to the other side, you get negative 2, and a is negative 1 over 3. So that will give me positive 4 times a, right? So that is fine, positive 4 times a is there, and I have a negative, this is d, right? Why do I say d? Because I'm substituting this value of a. A is equal to negative 1 over 3, right? That's what I got. Okay, let's see, and I'm adding it with negative 2d positive 4 times c. So this is going to be 2 times d positive 4 times c is equal to negative 2. So I have a system here and I have a system here. So this is, let me take this as say 5 and 6. So I will equate 5 and 6. What is going to happen here? You see that I can equate these two. So this is going to give me negative 2 times d positive 4c is equal to 2d positive 4 times c. Now apparently, if I were to bring this side, this will be negative 4 times d. If I were to move this side, it will be 4c negative 4c. So I get a 0 here. So that would mean my d is 0. My d is 0. If I were to place d to be equal to 0 here, what happens to c? D is equal to 0, then this will mean a is equal to 0. Okay, and then d is equal to 0. This in turn would mean 4c is equal to negative 2 and c is equal to negative 1 over 2. Wow, beautiful. Right? This is one of the way to find the values. There are other ways also. So let me go back over here. This is the original integral. So let me take this as sum a. I'm going to flip the paper and rewrite this. So therefore a can be rewritten, the equation a can be rewritten as a is 0. So 0 positive b is 1 over 2 divided by u squared, positive c is negative 1 over 2, negative 1 over 2, d is 0, so you get 2 positive u squared. Okay, so we need to integrate this. So therefore integral of du divided by u squared of 2 positive u squared is this, right, times du. So this is going to be equal to 1 over 2 times integral du divided by u squared negative 1 over 2 times du divided by u squared positive 2. So this is rewritten as 1 over 2 times u raised to the power of negative 2 times du negative 1 over 2 and integral du over u squared positive 2. Okay, now this is going to be root of 2 raised to the power of 2. I want to get that formula, integral dx over x squared positive a squared, which is equal to 1 over a tan inverse of x over a positive c. Okay, so I take 1 over 2 out. This is going to give me u raised to the power of negative 2 positive 1 divided by negative 2 positive 1, followed by a negative sign 1 over a, which is root of 2 tan inverse of u over root 2. This is what I've got. Now I can rewrite this 1 over 2 times u raised to the power of negative 1 divided by negative 1, negative 1 over root 2 tan inverse of u over root of 2. This will be rewritten as 1 over 2 times 1 over u with a negative sign, negative 1 over root of 2 tan inverse of u over root 2. Now I can take the negative sign out, so it's going to be negative 1 over 2 times 1 over u. What is my value for u? Let me show you the value of u. U is nothing but tan x, so substitute that. So I get 1 over tan x positive 1 over root of 2 tan inverse of tan x divided by root of 2 positive arbitrary constant. So that is the solution for this question. Please like, share and subscribe. Thank you everybody.